Hi, I'm Sean from my maths trainer, and this is Differentiation 1 for Leaving Cert Higher Level and Ordinary Level. This is a follow-along lesson, so everything that we use is going to be on the My Maths Trainer app. You can sign up for free at mymathstrainer.ie. All the lessons and exam papers that we'll use today, they're going to be up for free up until New Year's, so hopefully you can use this for revision for your mocks. If you come across the video after New Year's, just drop me a message in the comments and I'll try to sort you out. And also, if you have any tips or tricks or anything like that for YouTube, I'm quite new at this, so things like, I don't know, mentioning I love YouTube as many times as you can during a video might push it a bit more. But yeah, let's get started. Okay, why we're starting with differentiation, it is one of my favorite topics to teach, first of all. It's incredibly practical. You can apply it to different real life contexts, things like roller coasters, speed and accelerations that goes around a course, or like the volume of a snowball as it melts with time. So it's really practical. It's also guaranteed to come up for paper one short question for both Leaving Cert ordinary level and higher level. And it bleeds into a long question, particularly at higher level on paper one and paper two. So we'll go through that as we go through the topic. This is going to be the first video of a series, I think. Let me know in the comments if you want any more. This is just the introduction and how it works. Things like first principles for higher level only as well. My second video, if you want me to make it, is going to be about the applications, so things like equations of tangents, maximum, minimum points, and then the rates of change as well. So we'll see how we go. Okay, differentiation is describing how a function changes over time. You might hear your teacher explaining or describing it as the rate of change of a graph. It's kind of the same thing, but I'm going to use slope to describe it here. So looking at this graph, I want you to think about what the slope of the tangent at any particular point is doing. So this graph, for example, the slope of the tangent is really negative, but actually it kind of slows down a bit as it comes down to the local minimum point or the minimum point. Here it's actually 0, if you have a look at how horizontal that red line is, and then it kind of takes off a bit as it comes across the other side. So that's what we're doing with differentiation. We're describing the slope at any particular point. Now, a few things that you need to know. If in the exam they give you y equals, so they give you the equation rather than the function, so y equals, then the derivative is going to be dy dx. So that's one way of saying it. Another one is if they give you a function, if they give you f of x, and they give you, let's say, x squared in this case, then I'm going to use f prime x for the notation. So this is just another way of saying the derivative. Now the beauty about differentiation in this, and if I'm just going to do this both ways, let's have a look about what the slope of this function is doing. So we already kind of discussed it when it was up here. It was really, really negative. I'm going to use the top as a positive part and the bottom as a negative part. But at the very beginning, the slope is really, really negative. So it's like down here somewhere. As it gets closer and closer to the point 0, it actually becomes less negative as it kind of levels out a bit. It gets to 0, and then as it takes off on the other side, it actually gets really, really positive again. Now that is a linear graph. The slope of that is, or the equation for that line is 2x. And you can kind of see what's happening here. I'm bringing the power from the top, I'm bringing it down, and then I'm taking 1 from the power. Technically, that's 2x to the power of 1. And this is why differentiation is just so nice, that you can actually just apply a very simple trick to it, and it will tell you what the equation for the slope is immediately. Okay, so let's talk about some basic methods. And now the power rule is what we've just explained a second ago. So if I have a function in the form axn, the derivative is anxn to minus 1. So what I'm doing here is I'm bringing that power down and I'm multiplying by it, and then I'm taking 1 from the power. Okay, so I'm going to go through a few examples of this. Let's say I had x to the power of 1. Now if I bring that power down to the front, it's 1 and then x, and then take 1 from the power is 0. Now anyone who knows your powers, anything to the power of 0 is 1, so that will just go to 1. If I have x squared, I've already covered this, the 2 comes down to the front, and then I have x to the power of 1, and x to the power of 1 is just x, so we don't need a 1 there. If I have x cubed, I'm going to bring the power down to the front, so 3x squared, and I'm going to take 1 from the power. That's where the squared comes from. And this goes on and on. Now, I'm just going to do a bit of a harder example. Let's say I have 4x squared. I'm going to bring the power down, so let me leave the 4 at the front. I'm going to have 2x. I'm going to take 1 from the power. And then I can simplify this a bit. So 4 times 2 is 8. And then x to the power 1, or just x. Okay, so that is our power rule. Let's go through a few examples. So if I have f of x equal to x to the power 5, find the derivative. I already know what's going to happen here. I'm going to bring the 5 down to the front and take 1 from it. So that will go to 5x to the power 4. And this is your working out. So 5 comes to the front, take 1 from the power. If I have minus 2x cubed, so let's have a think about what's going to happen here. I'm going to have minus 2, and when I bring the 3 down, I'm going to multiply by it. So it's minus 2 times 3 is minus 6. And then take 1 from the power, so the 3 becomes a 2. And here's your working out, so minus 2 times 3, and then take 1 from the power. The constant rule is a bit more difficult. Now, I just want you to consider this. So let's say I have f of x, or I'll use y in this case, y is equal to 3. So dy dx is going to be the notation I use for this one. Now, technically, I'm going to have x to the power 0. I already kind of discussed how x to the power 0 is going to be equal to 1. So let's say I have 3x to the power 0. I'll leave the 3 outside. So I'm going to have 0x to the power minus 1. And anything to the power, or anything multiplied by 0 is going to be 0. Now, in practice, this means that any constant, when it's written by itself, is just going to go to 0. So, for example, f of x is equal to 7. And I'm just going to do a quick diagram of what x to the power x7 looks like. So if f of x is equal to 7, that is just a horizontal line. And I know the slope of that line is going to be equal to 0. So I have f of x is equal to 7, and f prime x is going to be equal to 0. And that is true for any constant. The next one I'm going to do is the sum and difference rule. So this basically says if I have a function that has 2 or more terms in it, then I can just differentiate the terms separately. So if I have x cubed plus 2x, find the derivative, I'm just going to differentiate them one at a time. So x cubed is going to go to 3x squared, and 2x is going to go to just 2. Remember, technically there's x to the power of 1 there. Same thing here. I'm just going to, I have 3 terms. I'm just going to differentiate them separately. So 3x squared will go to 6x. The 2x will go to 2. And the minus 1 goes to 0. So any constant will go to 0. And match each function with its derivative. So x cubed, we already know that goes to 3x squared. The 3 comes out to the front. Minus 2x squared is going to be minus 2 times 2 is 4. And then x to the power of 1. So minus 4x. Any constant goes to 0. And x, technically that's x to the power of 1. That will go to 1. Okay, before we move on, there is a basics examples lesson there. You can go through that in your own time. But I'm going to move on to evaluating derivatives. Now, evaluating, it's often used in substitution, but it just means that I'm going to substitute a value of x into the derivative. So evaluating derivatives, it basically means that I'm going to find the slope at a particular point. So going back to my diagram, if I wanted to find the slope when x is equal to 1, I would differentiate it, and then I'd sub in the x value. So that'd be 1. Let's have an example here. So if x is 2, I know the slope is really, really steep here, and it's going to be positive. So if I differentiate, and then I'm going to sub in 2, I'm going to get a pretty big answer. And then if I go this way, let's say I go to minus 1. If I differentiate and sub in minus 1, I know my answer is going to be a negative. And it's going to be an even bigger negative number if I put in, let's say, minus 2.5. So the steps are going to be differentiate the function, I'm going to substitute the value in for x, and then I'm going to simplify to find the derivative, or find the slope. So this is my question. I have x to the power 4 minus 3x squared plus 2, and I want to find the slope when x is equal to 2. And this is just an example of what that graph looks like. It's a quartic, so it has 3 turning points. And x is equal to 2. I know the slope of that line is really, really steep, so I'm expecting a big number compared to, let's say, if it was 1, it wouldn't be as steep. But for 2, it's going to be a big number. So this is my sum and difference rule. I'm going to differentiate each one separately. So x to the power 4 will go to 4x cubed, minus 3x squared will go to 6x minus 6x, and then any constant will go to 0. Now I'm going to substitute in, so this is what my derivative looks like. If I put 2 into this, 2 cubed is 8, times 4 is 32, minus, and then 6 times 2 is 12, so 32 minus 12 is going to be 20. Perfect. And just to go back, again, we're describing the slope of that line. The slope is 20. Okay, the next one, let's say I have 2x cubed minus x. I want to find the slope when x is equal to minus 1. So I'm going to differentiate each one individually. 2x cubed, that's going to go to 6x squared. And then the minus x will go to minus 1. And I need to evaluate that when x is equal to minus 1. So I'm going to put minus 1 in here. 6 times minus 1 squared is 6 times 1, which is 6. And then minus 1 is 5. Perfect. Okay, there's a few more examples here. So I'm going to differentiate and evaluate when x is equal to 3. So differentiate each one and then sub in 3. If I differentiate this, I'm going to have 4x, and 4 times 3 is 12. I have 18x. When I differentiate that, that's just going to go to 18. I don't need to sub in 3 to that one. And 4x squared will go to 8x, and 8 times 3 is 24. So I'm going to go through some exam paper questions now. These are both from 2025 Leaving Cert Ordinary Level. This is question 4b. And you'll see how repetitive these questions can be. So let's zoom in on this. I have x cubed minus 3x squared plus 4x minus 8. If I differentiate each one, I will have 3x squared. So let me type that in. And the minus 3x squared will go to a minus 6x. So minus 6 and x. The plus 4x will go to plus 4. And the minus 8 is going to go to 0. So that's my derivative. So differentiate each term, and that's my derivative. Now I want to find the slope of the tangent when the point is equal to 2 and minus 4. So the x value I'm going to use is 2. So I'm going to sub 2 into this. 2 squared is 4 times 3 is 12. Minus 6 times 2 is minus 12, and then the plus 4 just stays the same. And if I have 12 minus 12 plus 4, that is equal to 4. And just quickly having a look at the other exam paper question, so this is 4C. And in this one, they wanted you to describe what happens at these 3 points. So remember, we're talking about the slope at these 3 points. So what is the slope going to be at P? What is the slope going to be at Q? And same thing with R. So I have 3 options. Point P, I have the slope is bigger than 0, it's less than 0, or it's equal to 0. Now at Q, imagine what the line is going to be looking like. That's going to be a negative. So I'm going to have Q is going to be less than 0. At R, it's going to be really positive because the line is going to go up. So R is going to be bigger than 0. And then at P, it's going to be flat completely. So the slope is going to be equal to 0. So P G prime X is equal to 0. And just really what they're trying to do, they're trying to be tricky with using the different notation here. So just be careful. Okay, so the remainder of the video is just going to be for higher level. If you're doing ordinary level, you can skip to the end or you're finished. Go onto the app, try a few different questions. There's more exam paper questions up there as well for differentiation, so give it a go. For first principles, this is basically the theory behind differentiation. Now, I know we're talking about the slope. Again, try and reinforce that in your head. Anytime they're talking about the derivative, they're talking about the slope. And this is my formula, y2 minus y1 over x2 minus x1. Now this works for a slope of a line because I have 2 particular points, but in a curve, it's actually going to be different. Like the slope of that line doesn't work anywhere along the graph. So what I'm going to do is I'm going to pick 2 points, and I'm just going to try and make them as close as I can to each other until they're practically the same point. So I have 2 points here. I have x and I have f of x. So this is just your x value and your y value. And then I have x plus h and f of x plus h, and this is your other points. And what I'm going to do is I'm going to make that difference h as small as I can. I'm going to essentially make it 0. So I have f of x plus h, this is your y2 minus y1 over x2 minus x1. And when I simplify that, the x's on the bottom line are going to cancel. And again, I'm going to make the h, the distance h, as small as I can. So I'm going to find the limit as h tends to 0 or turns into 0. So I have y2 minus y1 over x2 minus x1, but I want the distance between the points equal to 0. And these are your steps that you need to know. So I'm going to find out what f of x plus h is. This is the hardest part. I'm going to subtract f of x, so only terms with a h should be left over. Divide by h, and I'm going to make h equal to 0. So any h terms, I'm just going to have a 0. So let's go through an example. It's quite easy when you get into it. So f of x is equal to x squared. I know my answer is going to be 2x here. So I know if I'm going to be right or wrong by the time we get to the end. You do need to remember what the formula is. So it's y2 minus y1 over x2 minus x1 as h tends to 0. I'm going to find f of x plus h. So this is the hardest part. So if I subbed in x plus h in for x here, I'd have x plus h squared. And if I square that out, I'm going to have x squared plus 2hx plus h squared. Now I'm going to go to my second step. So I'm going to take away f of x. And again, you're just basically getting rid of anything that doesn't have a h in it. So I have 2hx plus h squared when I do that. So I have those two take away each other. Then I'm going to divide by h. So 2hx divided by h is just 2x, and h squared divided by h is h. And then anything that has a h left over, it's going to 0. So I'm just going to have 2x left over. So that was my first one, my second one, and my third one. And this is my full solution, so just have a look. I have f of x plus h, so find out what that is. I'm going to sub it in and then expand it. I take away f of x, so anything that doesn't have a h in it, we're going to get rid of. I'm going to divide by h, so 2hx plus h squared divided by h is that. And then find the limit as h tends to 0, so any h is left over is just going to go to 0. So I have 2x as my answer. Let's go through another example. So 13x squared from first principles. I know my answer is going to be 26x here, but write down the formula. That's going to get you marks on the day. I'm going to find out what f of x plus h is. So if I sub in x plus h into f of x, I have this. And if I multiply that out, I'm going to have 13x squared. I'm going to have 26xh. And I'm going to have 13h squared. Again, this is the hardest part. Once I have that, I'm going to take away f of x. So anything that doesn't have a h in it is going to go. So I'm going to have 26xh plus 13h squared. I'm going to divide by h. So I'm going to have 26x plus 13h. And then again, anything that has a h in it is going to tend to 0. So my answer is just going to be 26x. I'm going to show you what an exam paper looks like. There's other examples that you can go through, but we'll go through the exam paper question instead. And differentiate from first principles, x squared minus 7x minus 10. So write down your formula. Again, this will get you marks in the day. I'm going to sub in x plus h into that. So if I have x plus h squared, that is going to be x squared plus 2xh plus h squared. And then if I sub in x plus h into that, I have minus 7x minus 7h. I'm going to take away f of x. So anything that doesn't have an h in it is going to disappear. So I'm just going to have 2xh plus h squared minus 7h. And then I'm going to divide by h. So I'll have 2x plus h minus 7. And then anything that has a h in it, I'm just going to tend to 0. So I'm going to have 2x. And I'm going to have a minus 7. And that's my answer. Okay, now the final part of this video is all about advanced differentiation. This is just really about awkward powers, and this is only really for higher level. So if I have something like 1 over x, I need to simplify that power first. So 1 over x is x to the power minus 1. And then I'm going to differentiate. So I have g of x is equal to x to the power minus 1. When I differentiate that, it's going to be minus 1 x, and then I'm going to take 1 from the power. So it's going to be minus 1 x, and then to the power minus 2. So just have a look at this one. I've brought the minus 1 down to the front, and when I take 1 from the power, minus 1 is minus 2. And I can simplify this. This isn't necessary for exam paper questions. I'll show you in a second. Often it's easy to simplify. So I'm just going to take x to the power minus 2 here. That negative power is going to bring it to the bottom of a fraction. So it's going to be minus 1 over x squared. So again, I'm just from this step, that minus 2 is going to take it to the bottom of the fraction. The other awkward one is the square root. Now, if I want to simplify that, I'm just going to write the square root as a power first. So that's going to go to x to the power of a half. And when I differentiate that, it can be a bit complicated, so I need to stick with it. I bring the half down to the front. So I'm going to have half of x, and then to the power of, and a half minus 1 is minus a half. So let me show you working out for that. After we simplify, I can bring that minus half, that's going to bring it down to the bottom of the fraction, and half, x to the power of a half is a square root, so it's going to be 1 over 2 root x. And again, yeah, let me look at the working out here. So change the power first, x to the power of a half. When I differentiate, it's going to be half x, and half minus 1 is minus a half. And then the power will come down to the bottom of the fraction and put in your square root again. And quickly, let me go through an exam paper question to show you this in practice. So this is 2022 question 5 from paper 1. And I want to differentiate x squared minus 1 over x. Now we've kind of done this one already, but I'm going to simplify it first. So a half 1 over x is equal to x to the power minus 1. Sorry, this is what the function looks like now, x squared minus x to the power minus 1. When I differentiate that, x squared is going to go to 2x. And this is going to go to minus x to the power of minus 2. Now just be careful of your signs here, so the next step I'm going to have to simplify that, but just differentiate one part at a time. It's going to be minus x to the power of minus 2. And the minus times a minus will give me a plus. So 2x plus x to the power of minus 2. Now you can simplify this to 1 over x squared. It wasn't needed in a marking scheme, so you can leave it the way it is. And often they'll ask you for a derivative or a value for the derivative, so you might have to substitute into that. But that was absolutely fine for full marks. And that is it for differentiation 1. So we've covered the basics, first principles for higher level only. We went through a few exam paper questions evaluating the derivative. Again, it's just finding the slope at a particular point. So differentiate and sub in a value of x. And then we also covered some harder things like how to differentiate the square root of x or 1 over x, things like that. Let me know in the comments if you want me to continue, which will be equation of a tangent and finding the maximum and minimum points.